Let's say that part of your application involves querying a database. You've defined a specific language for doing so. Wouldn't it be nice if each part of your language had its own syntax color? What we're going to do in the screencast is create syntax coloring for our domain-specific language for querying a biology-related database. First, you see we have here a text field. So this is a plain, normal, standard J text field. However, we're not able to associate a MIME type with a text field. So instead, we're going to replace our text field with an editor pane. Here's an editor pane, and we paste it into our application, into our top component, and then we go to the properties of our editor pane, and we specify that instead of text plain, what's going to be used here is text x bio. So this is a MIME type that doesn't yet exist. In addition, we specify the default content that's going to be displayed, and we are ready to continue. So here is our Java CC definition. This could also be an ANTLR declaration. Here we can see a very simple definition file. First of all, defining what a white space in our domain-specific language consists of. Next, we see all our different kinds of tokens. So especially for the molecule, for the subtype, for the keyword, these three are the main items of our domain-specific language. In addition, we see some conjunctions, we see some punctuation, and also there is a special token type for a quoted string. So the content between two quotation marks will be treated as one specific token. Now what we're going to do is generate our lexer and parser related information from our Java CC file. So I've downloaded Java CC, and here on Windows you can see that we have a Windows batch file, which as it happens has special support inside NetBeans IDE. So let's now open the properties window, and when we do so we can associate an argument and a directory where this will be run. So first of all, whatever file we specify as the first argument to the Java CC batch file will be the file that is passed in. So that is our bio.jj file. In addition, we are going to specify, once we have typed in the complete path to our bio.jj file, we are going to specify the directory inside which the Java CC tool should run, which means that that is where the files will be generated. So a bit more space, and we can continue typing until we have the full path pointing down to our declaration of our language. There it is. So this is the full path to our bio.jj file, which could also be an ANTLR file, so it would be bio.g. And now that we have this, we can go ahead and specify the run directory that's going to be used. So instead of running this, running the Java CC command inside of the Java CC directory, we're going to say that it should run inside of a package inside our application. So we're going to run this, and we see that this package doesn't exist yet, so we need to go into our module and add that package. So we add a new Java package generated, and then we actually can run our Java CC file again, and we now have a whole bunch of files generated from Java CC, which again could also be ANTLR. We would have the same kind of result. So we look inside, we can see our tokens. So this is our molecule, our keyword, our subtype. Everything else that we defined in our bio.jj file is now inside this constants file. In addition, we have a parser that's been created for us, and we have a token manager. So these are all the standard files that you would always get if you're using Java CC to generate your lexer and your parser. Now that we have this, the next step is for us to integrate this into the NetBeans Lexer API implementation. So there is a tutorial that we're simply going to copy content from. So the first step is to set a dependency on the NetBeans Lexer API, which lets us integrate our generated Lexer from Java CC or Antler into the NetBeans Lexer-based infrastructure. So we start by including that Lexer module and any related modules, which in this case is nothing really except for one additional module. You can see here editor utilities. These two modules need to be included in our application. Once we have these in the application, we can set a dependency on Lexer inside our module. So if you look right through it, you see that all we've done is added our Lexer module plus one additional supporting module. So we say OK, and now because we've done that, we can add a dependency on the Lexer module. And now that we have the Lexer module, we can begin using the different classes that are referenced in the tutorial. So our starting point is to create a token IDE definition, and before we do that, we're going to create a new package. So .lexer, there's our new package. So now we're going to just copy classes from this tutorial. So the interesting and cool thing about this tutorial is that all the classes that you find in here that are described in here are standard classes that you don't even need to modify. You shouldn't need to modify them much, if at all. So first of all, we're going to define a class called BioTokenID based on the code that we copied from the tutorial. So we just paste it in here, and then we are going to change it so that instead of using SJ, which is the simple Java from the tutorial, we're going to use our own instead, our own BioTokenID. Oh yes, and we need to change our constructor because we have here a class called BioTokenID. Okay, so this defines a name for each token, it defines a category, and it defines an ID. Done. Okay, next is to create a language hierarchy definition. So you can see this is part of the Lexer API and the NetBeans IDE's set of APIs. Again, we're going to create a new Java class, in this case called BioLanguage Hierarchy, and here we're going to paste the content from the tutorial. Here's a new class. Say OK. Add the content from the tutorial, so extends language hierarchy. Copy the content. This is also where we're going to end up typing our token definitions later on in the screencast. So we paste, and instead of SJ token ID, we're going to need bio token ID. So we can replace them one by one, or we can do a search for all of them and replace them all in one go. And then we do a fix imports, and we can also, in addition to that, get import statements for each one individually, depending on how you want to do it. In the end, the only problem we are left with, and this is the place right there in that pending where we're going to add our tokens, and we are only left with one problem, which is the BioLexer we don't have. We need to define our MIME type, which we haven't defined yet, which is still coming up, and we have to create a BioLexer. So this Lexer class is also right here in the tutorial. So we can take this SJ Lexer and copy that, and so this is going to map the Lexer that was generated from Java CC with the lexing functionality in the NetBeans IDE's APIs. So we create a class called BioLexer, we return to the tutorial, we copy as is this entire piece of code, return to our class, paste it in, and again change SJ to bio, get the imports, okay, make some small changes. So before we had a character stream class called Java char stream. The one that was created for us is called simple char stream. So we make those changes. We also see we have a Java parser token manager. We're going to change that instead to be our bio parser token manager that was created for us. So it's some small modifications to the code. Not much work to do here either. BioQuery parser token manager is the name of the class. Finally, the simple char stream is going to now receive a class from our Lexer API in the NetBeans IDE's APIs. We're going to modify that character stream because JavaCC is going to, the first time it encounters some error, throw an error statement, and what we want to do is have it continue, as is explained in this tutorial. So we're going to jump into our simple char stream class and let it handle this input, and we're going to do that by again copying from the tutorial exactly as is and pasting the content of that class straight into all of this generated code, just overriding it, copying over it, fixing the import statements, changing the class names to match what we are now dealing with. So there should be Java changed to simple. We should get our import statements again, which we can do one by one or for the whole class. And we're still missing one for the unsupported encoding exception. And then there are some import statements at the top of the class that we no longer need. Let's remove them all. And we're good. Everything compiles. There are no problems. We've integrated the generated Lexer with the NetBeans Lexer infrastructure. Everything compiles and is going to work for us as we would expect. So now you can see that we are dealing with, in this class, the Lexer input instead of the standard input stream. And this is the bridge between what is generated by JavaCC and the NetBeans Lexer infrastructure. Next, we need to register this Lexer infrastructure that we have with the NetBeans system. So first of all, we have a static call that we're going to place inside our token IDE class. So here it is. So again, it says SJ instead of bio. We make that change. So from somewhere we need to call this now, and that will call the whole language infrastructure. The way that this is done is via a CSL plugins folder in the NetBeans virtual file system, which means we need to get hold of this common scripting language, which is the CSL infrastructure and its related modules. We're just going to clean and build the application to refresh everything and to get the modules correctly integrated into the system. Next, we are going to set a dependency in our module on common scripting language API so that we can register our language infrastructure. Here we see the SJ language class from the tutorial, so we're going to call this bio language instead. So here it is. We're going to copy the code as we did before and paste it into this class. Again, fixing the import statements, changing the SJ token ID. Also, this is the text that will be displayed in the options window. You can see here SJ is going to be bio instead. Finally, we also need to register here our MIME type. So this is where the MIME type is actually going to be created inside of the virtual file system. So when we build the application, the language registration annotation that you see here is going to result in new entries in the layer XML file for this module. So we look in classes meta-inf generated layer XML, and here we can see CSL plugins text xbio. There is our MIME type created, pointing to our language entry point. So here now we have our Lexer language infrastructure implementation from NetBeans registered in the file system. Next, we need to register our tokens. So remember that we have tokens generated by JavaCC, which we now need to hook into our right there into the language hierarchy. So again, we're going to modify SJ token ID to be our own generated bio token ID, or not generated bio token ID. This is what we created ourselves, and we are going to split the screen so that we can work with both of the classes simultaneously. So you see, first of all, bio token ID, the end of file is set to the ID ordinal 0. So we're going to continue that same way. White space is correct, set to 1. So and is really a conjunction. So we'll create a new category called conjunction and set the ID as defined in the generated tokens. So the same for OR, and we continue creating token IDs, so creating a new token ID for each of our different tokens that we are interested in representing. We're mapping each token to a different category, and each category is going to have a particular color, which means that in this case and OR are going to have the same color because they belong to the same category called conjunction. And so we continue. Our main items are molecule, subtype, and keyword. So these will get their own category so that we're enabling ourselves to set distinct colors for each of our main items in our domain-specific language. The other items we want to treat in groups, so and OR are going to have the same color because they're both conjunctions. The same is true for quote and single quote and semi and comma, because these are all different kinds of punctuation. You could consider these signs or punctuation. So this is a little bit of work, a little bit of manual work we need to do to integrate our tokens and register them under a particular category for our language coloring. Yes, punctuation is a better name. So this is what we're going to use as the category name for all the different kinds of punctuation that we'll work with in our domain-specific language. Semicolon is also punctuation. This is the most work we'll need to do in our domain-specific language syntax coloring work. The rest is all generated and copy-paste work. Right parenthesis and left parenthesis, we could have specific coloring for that, so we'll give those, assign those to their own distinct category rather than being punctuation. So ID 11 is set to left parenthesis and 12 to right parenthesis, and we're almost done. We have equals, not equals, which could both be considered punctuation, and then string and quoted string. These are both strings. So these we are going to expect to have the same coloring. So we'll assign them to the same category, string. Another approach to take here is to have this be generated. So instead of hard coding this as we're doing now, you could point to the parser constant file and generate from that each time you build the application your set of tokens. There are different approaches you might want to take. This isn't the most efficient for a very large language, of course. You would rather generate all your token IDs in that case. We're ready. So now what we're going to do is assign colors to the categories that we have just created. The way we do that is to create a fonts colors XML file and to register that file inside the virtual file system via the layer file. In our main package we create a new, not an XML layer file, but in fact a new XML file. that is called font and colors, and into this we can paste this content and then again tweak it to fit our needs. There it is. Okay, so now we can look at our categories and then type our categories in the places that we have here in the file from the tutorial. So we have white space, we have conjunction. Let's just start with the main ones. So our main ones, the ones that we're interested in really giving color to, are molecule, subtype, keyword. So here's red, molecule, subtype. So we can also set a default. So if we wanted to, we could have a different category called generic, for example, and then assign all of our different categories as a default to generic. So we could have two levels of coloring, but we're just going to set as the default the same category as we're using for the color. So subtype is here keyword. Keyword. We'll just choose some simple colors here. In the first iteration of our syntax coloring, we could make it more complex and more interesting and add bold and italics and other character styles like that. But for the moment, we'll just keep it simple and color the foreground of each of our important types. So we have molecule, subtype, keyword. What we also are going to need is a example file, and we're also going to need to register each of our different categories inside the bundle properties file, because this is what will be displayed inside the options window. In the options window, the user is going to be able to customize the colors that we have predefined. Maybe they don't like the colors that we have set during the programming of our application. So we're going to let them set different colors, and these are the display texts that they will see. If you look in the tutorial, you can see the other approaches you can take. You can see here that we have one too many subtypes there, and here are our properties. So molecule is one of them, which we set to molecule. We set subtype to subtype. We've made a small typo with the molecule that we'll fix later on. So subtype is going to be displayed as subtype. We could add spaces on the right hand side in the value. Keyword is set to keyword, and here we set the string to string, and the same thing we'll do for all the other tokens that we've identified. We won't show you exactly all that as well, but that's also what's going to be happening before we deploy the application. Next, once we've added a layer file, we are going to register the options window extension in here, and what we're also going to do is register our fonts and colors file. We don't need to register the language functionality because that has been registered via the annotation in the language class. So the only things we're registering here are the fonts and colors.xml file, which provides the mapping of the categories to colors, and the example file that will be displayed inside that options window. So we don't have that examples file right now, so we need to create that too. So that will be used by the user when they configure the options window. So this file biotemplate.bio doesn't exist yet. It could have any file extension. We haven't actually created a MIME type for the .bio file, but we don't need to do that, since we are not going to have files named .bio, but we're simply interested in having the editor pane being mapped to the MIME type text.xbio. And this, what we are creating now, is going to be shown in the options window. So we'll take the same content as we can see displayed by default in the top component, and we place that inside of our example file. Final step is to add one additional module, which is the Lexer to NBN to NB bridge module. Lexer to NetBeans bridge module. Once we have that module, the coloring is going to work in our application. We can start it up, and immediately you'll see our colors, not so great yet, but clearly working, and we can go back and fix those colors and then improve on them. If we now go to the options window and we switch to the fonts and colors, we can see that there is our syntax coloring for our MIME type. Thank you very much, and have fun with creating your own syntax coloring.